This is Dr. Holt. This lesson is on work and kinetic energy. This is going to be part 1, and I'll be dealing with just work. As far as work, when a force acts upon an object to cause a displacement of the object, it is said that work was done upon the object. There are 3 key ingredients you need to note for work. You must have a force, you must have a displacement, and you must have a cause. So in order for a force to qualify as having done work on an object, there must be a displacement, and the force must be the item that's causing the displacement. It is commonly said that work is force times distance. However, I want you to not really use that term because it's a little bit misleading, because the definition of work done on an object by a force is when the point of application of the force moves through a displacement. Being, if I have a force here and I apply it to this object, and this object moves from this location to this location, then the amount of work is nothing more than the product of the force and the displacement. So work is defined by the dot product of the force vector and the displacement vector. What's important about that is when you have, say, a force that's coming off at an angle here, and you try to do the dot product, you're going to have to get the force and the displacement to be parallel. So the force times the cosine of this angle times this displacement would be the work. Now work is a scalar quantity. It's not a vector quantity. The dot product of a vector quantifies it is always scalar, which means it only has magnitude and no direction at all. In this example, if the man is pulling up on the box and walks across the floor and the displacement is delta x, there's really no work that's being done on the box itself because the force that is pushing up is going upward in this direction, and the displacement is here. If you did the dot product, you'd get 0 because the force and the displacement are not parallel. Now the unit for work is going to be joules. And if you get into foot-pounds, then 1 foot-pound is going to equal to 1.356 joules. The electron volt, you'll see that sometimes in some problems. 1 electron volt is going to equal to 1.602, and that's supposed to be times 10 to the minus 19th joules. That is going to be the value if you come across a homework problem like that. Alright, let's look at this example here. Let me get out the highlighter. How much work being done on a 12 Newton force, how much work does the 12 Newton force do on the box? So in this case, go ahead and scroll down, you're going to have to break this force into a horizontal component. So I can take 12 newtons, I can multiply that by the cosine of 40 degrees, then I can multiply that by 3 meters. So when I do that, I'm going to get my calculator. I check my mode real quick. Yeah, I'm all set. Okay, I take 12 times the cosine of 40 times 3, and that's going to give me 27.58 joules. That's how much work is being done by this force to this box by pushing across the floor 3 meters. If you have more than one force being applied, you want to find what the net work being done on the object is. Let's look at a problem here that kind of clarifies that. I have a 1800 kilogram car traveling down the road, has 2 forces exerted on the car. 1,000 Newton force exerted on the drive wheels by the road, and a 960 Newton resistant force. Okay, so we know that if the car is moving down the road, and we're saying it's going this way, then the drive wheels are going to cause a force to go this way, and this would be 1,000 newtons. The resisting force is coming back. That's going to be 960 newtons. And we'll call this force resistant, and we'll call this force D for drive. Okay, and your displacement is 20 meters. So the work done by the drive wheels would equal to 1,000 times 20, or 20,000 joules. Okay, and we're going to let anything goes this way be positive. So that does that amount of work. Now the resistive force is pushing backward. So the work done by the resistant force is going to be negative here because going the opposite direction. It's going to be 960 times 20, and that's going to give us 19,200. So that's the work that each one of these forces are going to do as the object moves 20 meters. So the net is just going to be the difference between those two, and the net would be 800 joules. Alright, so that's the net work that's done to the object. Alright, so then the next video I will get into energy.